And we have to figure out the last thing we needed to do with this. Now, let's review a little bit of this. This is a metric model, so we have to use negative 9.8 t to the squared plus v naught t plus h naught. Okay, now, shh, ladies, quiet down. Our initial height was 1.9 meters, so that's our initial height, our h of 0. Ladies! And our initial velocity is 8.1, so that's where we put our v sub 0. And we went ahead and did a little sketch of this. If you plug it into your calculator, your calculameters, you're going to have to mess with the window a little bit. And we ended up with a x max of 5 and a y max of 5. And I personally didn't need the negative number, so I made it -1 for y min and -1 for your x min. So that when we went to graph that, we're looking at this basketball shot, right? Now, we're supposed to find when this ball goes through the hoop. And that hoop is 3.05 meters high. So from here to here, it's 3.05 meters high. Now, I was going to show you guys how to solve this algebraically, but then I realized we haven't done that yet. So, what we're going to do, the initial height was 1.9. So what we're going to do is, we're going to do this in our calculameters. We're going to put this in our y1, and we're going to put this in y2, and we're going to see where they intersect. So, I've already got, oh, looks like I screwed this up again. Okay, so I'm going to put this, actually I'm going to put this one on y1, doesn't matter. Negative 9.8, 8.1, and 1.9. And then in y2, I'm going to put my 3.05. I should get a curve and a line when I hit graph. Okay. Now this line represents where these two Now I don't want the first intersection, do I? Because your basketball actually has to travel and then it goes in, right? So I need the second point of intersection here. Comprendes? Comprendes? So I'm going to go back to calculate. So I'm going to hit my second button, trace, and I want an intersect point. So I'm going to scroll down to intersect and hit enter. And then it's asking me for my first curve. Let's see where my... Okay, so there's my my cursor. It's asking me, is this the first curve? I'm going to hit yes. So I'm going to hit enter. Now I'm on the line. Is this my second curve? I'm going to hit enter. And then it's going to ask me, well, do you want me to guess where that point is? And I'm going to hit enter again. And it gives me the point. Now, the point of intersection is 0.64. The point of intersection is 0.64 and 3.05, which I expected because that's where it's supposed to be. Now, it's asking me how many seconds until it reaches the hoop. It reaches the hoop at 0.64 seconds. Isn't that easy? That's wonderful. Now you guys have all this mathematical modeling knowledge. Okay, last one I'm going to do, and then you could do the entire practice worksheet. I highly suggest that you do it in class because many of you don't have graphing calculators at home. All right, number 4. Okay, the area of a rectangle shown is 105 meters squared. Find the value of x and the dimensions of the rectangle. Okay, so how do I find the area of the rectangle again? Area of a rectangle. That's right, length times width. Okay? They give us some information. They said, well, the area is 105. The length is x, and the width is 2x plus 1. Now, we did do some equation solving if you want to solve this, but we could also put this in y1, y2 like we did before. Now, the only thing is, this is going to be in one of your y's, y1, but you're going to have to put this in y2. But you're going to have to, you can either distribute it or put it in exactly like it is. So, let's clear out what we have. I have my y1, 105, and then in my y2 I'm going to put x times 2x plus 1. Then I'm going to hit graph, and it's out of my window. So I'm going to have to change my window. This is the one that's probably screwing it up. Okay? My y equals 105. I think my y max I put at 5. So I'm going to need to put my y max at around 110 or so. So I'm going to go to my window, go to my y max, and put it at, oh, I don't know, 110. Then graph it. And I still, guys, quiet. Okay, I changed my y max to 110 because it's at least 105. And actually, I probably could use a little more room. So I'm going to change it to 120. But now, I need to pick up this intersection point out here. So I'm going to have to increase my x max. Okay? Because I got it set at 5. I might increase it out here to 10. So I'm going to go back to my window. And I'm going to increase my y max just to give me a little bit more room at 120. And then my x max, I think I'm going to maybe increase it to 10. Let's see if we can pick up that intersection point. And we can. We did. Okay? You guys have to know how to do this. I don't mean to yell at you, but come on, you're getting a quiz on this Monday or Tuesday. And you guys have completely ignored me for the past 2 or 3 days. All right, so let's pick up the intersection. Second trace. Going to go to intersect. That's my first curve, is the line. I'm going to hit enter. My second curve is that parabola. I'm going to hit enter. And then enter again. It gives me the point of intersection. So my x equals 7. I mean, it's really easy if you guys get a calculator and do this and pick out these points. Yeah, I don't even know if I'm going to put this on Google Classroom because you guys really are not paying attention anymore. Okay? I have to because there were too many people not paying attention. All right, so the dimensions. Well, 7, and what do we got here? Meters. And it's going to be 2x. So it's 7 by 2 times x plus 1, which is 15. So it's 7 meters by 15 meters. Okay? You guys should be able to do the whole practice sheet now. It's pretty much what your quiz is going to look like. Just one section.